Hello, everyone. Welcome to the 12th edition of our Grammarly AI-NLP Club. My name is Vipul, and I'm an applied research scientist at Grammarly, based in San Francisco. And I'm really pleased to moderate tonight's meetup. And of course, welcome Dongyeop. So the main goals of the Grammarly AI-NLP clubs are threefold: to bring together leaders in the field, specialists interested in machine learning and NLP in particular, to contribute to the development of AI community in Ukraine, and last but not the least, these events are intended as an opportunity for you to connect with new and interesting people. So after the talk and the Q&A session, we are inviting you to a Zoom call to chat in an informal atmosphere. So you will have a chance to chat with our speaker, Dr. Dongyeop Kang, and the Grammarly team. The link to the call, you can find your registration confirmation, and we will also post it to the Zoom chat as well. So you're very welcome and encouraged to talk to each other. And so, yeah, and let me give a few more details about how this event is going to be conducted. So please feel free to submit your questions to the Q&A panel during the presentation. I encourage you to send your questions to hosts and attendees so that everyone can see your questions. And Dongyeop will make sure your questions are addressed during a few pauses in the middle of the talk, and of course, after the talk itself. And definitely there's an opportunity to ask Dongyeop anything during the networking session, so don't miss your chance there. So yeah, let's get on with it, get to the main part of today's meetup. And I'm really excited to introduce Dongyeop Kang. He is a postdoctoral scholar at the University of California, Berkeley, focusing on building interactive NLP systems. And starting this month, he will be joining the Department of Computer Science and Engineering at the University of Minnesota, Twin Cities, as an assistant professor. He obtained a PhD in the Language Technologies Institute of the School of Computer Science at Carnegie Mellon University, where he studied linguistically informed language generation systems. His PhD study has been supported by the Allen Institute of AI2 Fellowship, a CMU Presidential Fellowship, and an ILJU Graduate Fellowship. During the study, he also interned at Facebook AI Research, AI2, and Microsoft Research. So please give a warm welcome to Dongyeop. And yeah, Dongyeop, over to you.
Okay, thanks, Vipul, for introduction. And I'm really excited to have a chance to talk to you guys. And I hope the talk will be really fun. Okay, let's get started. Okay, so my name is Dongyeop Kang. Just one second. Let me just move this window to the bottom. Okay, so my name is Dongyeop Kang, or you can just call me like a DK, which is my initial. That's also fine. And in today's talk, I will give you a very comprehensive view of how we can build more human-centered language generation system, or NLP systems in general, particularly focusing on two aspects. One is styles, and the other one is interactions. And feel free to interrupt in the middle of the talk if you have any questions, or if you put your questions, as Vipul said, put in the chat room. I'm gonna check them in a regular basis during the talk. Okay, let's get started. So while I prepare for this talk, I was curious how to make this talk more fun and interactive. So I just took a state-of-the-art language generation system called GPT-2 and then asked for some advice. And of course, this is a Grammarly talk. I used Grammarly to correct some of my typos, of course. So look at this. So my questions are like this, and I corrected some typo. Yeah, sometimes suggestion is not appropriate, so I just ignore. So you can see the output from the GPT-2 system. So the system says, I think you're a pretty cool guy. I want you to be my girlfriend. You're so funny and smart and pretty. The reason why we never talked is because blah, blah. Okay, let me stop here. And as you can see, the output from this system is like almost like random and incoherent, and they are not related to the topic of my question, right? So this lack of coherence is because the system has no clear like intentions for generation or clear goals to achieve throughout the generation. And there's no way to control the model's predictions, so generation becomes so random and out of control. And this lack of controllability makes the system less interactive with real users. On the other hand, look at the output from this Grammarly system. And even though the functionality of the system is limited to grammar checking or typos or some suggestions, but they're fully functional and they have a high accurate suggestions. Okay, then what is the gap between this practical system and this non-interactive random output generation system? How we can bridge the gap between these two NLP systems? And what other factors are missing in between them? So do you think if we upgrade my GPT-2 system to GPT-3 or GPT-100, do you think it can handle all these issues that we just saw here? So we're gonna answer these kind of questions in this talk, okay? And have you raised a parrots or macaw before? And how do you teach them to speak? So probably we repeatedly say like, hi, say hi, hi, hi. And then until the parrots follow the pronunciation. And if they do, we feed them a little treats or compliments. And then you keep increasing the number of words to apple or other words, and then mapping the words with the corresponding context. And do you believe these parrots are basically understanding your meaning of your text and thinking like humans do? Probably no, right? They are basically repeating the patterns they are given in order to maximize the reward in the given context, or just following the most frequent patterns in it. Then what is the difference between these parrots and the state-of-the-art NLP systems like chatbots or GPT-3 or other NLP systems? So in fact, in academia, there are some recent critics on this like limitation of these large pre-trained language models and what other factors should be paid more attention in our field. So there are so many good papers, good positional papers, and there are some recent debates. What would be the next deep learning? Like what is the deep learning 2.0, something like that, and what other contexts should be considered beyond the surface text and so on. So I really highly encourage you to take a look at these some positional or theme papers if you're interested. Okay, so then again, what factors make NLP systems more human-centered or human-like? So NLP researchers in our field have been studying various factors. For instance, the systems needs to produce factual and trustworthy outputs. The systems needs to do some numerical reasoning, temporal reasoning, spatial reasoning, etc. And they need to understand social and pragmatic context. When the system generates a long document, the sentences in the documents should be coherently connected to each other, and they should be under control with respect to the goal of the generation. And most importantly, the system shouldn't be a racist or producing some offensive languages to certain group of people. And as you have seen in the previous example, our current best systems, NLP systems, are far from these factors, right? So my approach to develop more human-like or human-centered NLP system is by combining the three different fields together. So one field is called linguistics, computational linguist or cognitive science. The other one is machine learning or deep learning. And the third one is human-computer interaction. So I do believe by intersecting these three fields together, we can achieve the human-centered system. So for instance, we should think about how humans produce language. Language itself is tightly coupled with humans' cognitive behavior. And based on that, many linguistic theories have been developed. And without studying them, we can't form a human-like system. And in my work and also PhD thesis, I used different social linguistic theories as a fundamental, like a theoretical framework of my work. Second, over the last decades, many powerful machine learning and deep learning models have been developed, especially in the NLP area, such as like attention or self-supervised model, contrastive learning, etc. And using these powerful models, we could effectively develop computational models to handle these linguistic theories. However, one drawback of this machine learning only system is they don't generalize well to out-of-domain samples or unseen patterns. So if new patterns of inputs are given, the system is so fragile and easy to make unexpected output, as you have seen in the previous example. So in the last part, we need to develop more practical and robust NLP system. And I believe we can do this throughout the interactions and collaborations with the real users. So in summary, my group's research goal is to build human-centered NLP system by developing interdisciplinary methods driven by theories, and also building interactive NLP systems for real-world applications. Okay, so that's most of the introduction. And in today's talk, I'm going to cover three things. So I'm going to start from the social linguistic theory that I used as a theoretical framework in my thesis work. And then I will study about one of the linguistic aspects, which is called style. And then I'm going to show you how we computationally model the style facets in NLP or NLG systems. And at the end, I'm going to briefly introduce some interactive NLP system that we recently developed. Okay, any question before I jump into the theory part? Let me check. Okay, probably no. Okay, so let's start from let's start from the original question again. What factors are needed to develop human-like NLP system? Some people may think like every information is included in the surface text, which is basically human written text. So training huge and larger model on a bunch of surface text might be enough. However, there are many other different kinds of implicit information under the surface text, just like a tip of an iceberg here. So without understanding these implicit information, the output from the system is underspecified and the system cannot proceed reliable generation. So here is an example of a dialogue between two people deciding which restaurant to go for dinner, okay? So they first greet each other and suggest some options like Korean, Japanese, American for menu and make an appointment at the end, right? Like a typical, like a daily communication. So what happens if you simply train your dialogue system using this written surface text? Your model probably is very good at memorizing all of this dialogue pretty well, but they will never work on the slightly different context. Why? To make this model to talk like humans do, like this, in many other different cases or generalized cases, different implicit information needs to be considered beyond the surface dialogue text. For instance, let's look at the beyond that surface, okay? In order to produce the surface text like, honey, I'm here, then the model needs to understand the relationship with the listener and how close you are with the listener, right? To understand the utterance like, I skipped the lunch today, then we need common sense knowledge and its reasoning like skipping lunch makes you hungry, so I'm going to suggest you what to eat for dinner today, something like that. So we need some sort of reasoning, right? To produce a long text utterance like this, or make the entire dialogue and multi-turns of the entire dialogue in a coherent way, we need to set a specific goal, like, oh, let's decide a restaurant to go for dinner. And then make all the utterances or all the sentences in the single utterance should be connected coherently. So in my work, I'm gonna call this individual parameter as facets. And my PhD thesis was mainly focusing on how to incorporate these implicit facets into generation systems and develop facet-oriented generation system. That was my entire PhD work. And so far, we found these multiple facets in this particular example, right? But then the follow-up question is, what types of other facets are there in general in human language? So 1961, a famous social linguist called Michael Holliday developed a theory called systemic functional linguistics, or shortly SFL theory. And in that theory, he defines three meta functions that consist of human language. So the first function is called ideational. So it decides what to say, like the dinner topic in the previous example, or like a common sense knowledge, like a skipping lunch makes you hungry and their corresponding reasoning. So that's called ideational function, okay? The second function is, once the topic of your communication is decided, now you need to produce multiple sentences and then structure them in a coherent way. So in the previous example, with the goal of deciding which restaurant to go, the agents greet each other first, ask for options to choose and make an appointment, and they are all like connected coherently over the dialogue. So this is called textual function. The last function is called interpersonal. So it considers all other interpersonal formulation of communications and develops social relationships with others. So depending on the relationship with the listener, like a couple relationship in the previous example, your utterance should be more romantic and friendly when you talk to your wife, or when you talk to your like a girlfriend, right, or boyfriend, right? If you say the same topic to maybe your friends or your boss, then the output should be totally different, right? So these individual facets like a common sense, goal setting, relationship, etc., then can be grouped under each of these SFL functions here. And only when these three functions are dynamically connected, we can produce human-like outputs. That's what the SFL3 say about. And then I extended this theory to build a hierarchical ontology of these facets, where each category consists of different subfacets. For instance, under ideational function, we have mode, topic, knowledge, reasoning. Under texture, we have goal setting, ordering, discourse, abstraction. Under interpersonal, we have personal, affective, figurative. As I will not cover all the details today, and it is actually impossible to propose a perfect ontology of every facet. But the major point here is that we have to know what facets we are studying on and define the exact scope of our work under this complicated facets of human language. And we ideally not just oversell your work. So during my PhD, I focused on particular subfacets like this gray shaded parts, and then regroup them and then call them knowledge, structure, and styles. So for instance, I developed NLP or NLG systems that can handle each of these facet groups. So for instance, in the knowledge facet group, I studied how to incorporate knowledge base, rules, logics into text, and then produce more factual or produce more knowledge augmented outputs text. In structure facet group, I developed generation systems that can adopt discourse structures and then produce more coherent long text. In style facets, I studied how to make the model produce more stylistically appropriate text. So among the three facets here, today I'm gonna mostly focus on the style facets. But I'm happy to have an offline discussion, or in our networking session, we can talk about the other facets as well. Okay, so before starting about the style section, I will pause for a few seconds and take questions. Could you tell, please, if slides will be shared? Yes, I'm gonna share the slides for sure, and or other, yes. I'm gonna share the slides, and in the slides, you can see the link to the papers as well. Any other question or thoughts? Okay, then let me continue. So let's getting into the style session. So style facet is tightly connected with humans, as I said. It's interpersonal facets. So, and because of this, it's quite tricky to define what's the role of style in generation or NLP. And also it's really difficult to empirically measure its effect. And before we start, I will give you I will give you a question first and then think about it. So what is style in language? Why is it important in language generation or NLP systems? Think about it. Okay, so here's an interesting user study conducted in South Korea. And in the study, they asked participants who work at companies like a Grammarly, and they collect their mobile messages related to the meaning yes when they respond to their boss or supervisors. And then they're all written in Korean, but they are basically meaning like yes, yep, yeah, or yeah, haha, or yes, sir, or yeah, haha, something like that. They're all like a different variation of yeses, okay? And then they project this different variation of yeses into two dimensions. The first dimension is how polite or impolite they are. The other dimension is how active or passive they are. And then in the reports, they said, oh, you better not to use yes, that, or yep, colon to your boss because they sound very passive and impolite. And then, oh, you better say like yep or yeah or yep, haha, make in order to make your communication more smooth. And then yes, sir, or yes, sir with exclamation mark will be the best in order to show your respect to your boss. Of course, these findings highly depend on cultural and pragmatic differences across countries. For instance, in South Korea, we use more respectful languages to the elder or supervisors than Western countries like US. So, but the main message here is, even though these different variations of yeses have the exact same semantic meaning, yes, right? But their stylistic meaning is totally different. And this stylistic meaning difference derive totally different social relationships. So this is why style facet is called interpersonal aspects, and why is it important to make the system more human-like or human-centered. Okay, so and in fact, there are many other like a style research in our field. Some people are working on how we can detect the sentiments from the text, how we can detect the emotion from the text, how we can detect politeness from the text, and so on. But most of them are conducted on the individual particular style type. The main assumption of my style research is that style is not a single variable. So I believe language is formed by a complex combination of different styles, such as politeness, activeness, formality, sarcasm, emotions, etc. And without understanding how these different styles are correlated each other, the model can't form a complete linguistic variation of these multiple styles. So that's my view, which is called the cross-style view. And here's a metaphor about this cross-style view. So imagine a orchestra. So what we hear from the orchestra is the harmonized sound of complex combination of individual instruments played. And then in the middle, a conductor controls their combinatory choices like a tempo or scores. And some instruments are similar, like a violin or cello, they are making similar sounds. Similarly, in language, text also reflects complex combination of multiple styles, and each has its own choices of lexical, syntactic features. and consistent combination of them by the speaker or the conductor in the orchestra metaphor will produce more stylistically appropriate outputs or more harmonized sound in orchestra metaphor. So we're going to explore this co-varying patterns of multiple styles and how they can effectively used in NLP applications. Okay. So, but before that, since there's no benchmark set of these multiple styles annotated together, so we collected ourselves and then we call it XLU. So XLU consists of 23 style data sets, 23 data sets, and some are from the existing data set and some are collected by ourselves. And we have collected a total like 15 different unique styles. And we group them into 4 different groups. The first group is called personal. This group is about the styles about the speaker. So maybe if you're born in South Korea and if your age is like 20 or 30 something, you may have your own like a style of speaking or writing, right? Your identity. So based on this demographic information of yourself, people may understand or catch your own writing or speaking style. On the other hand, interpersonal style is about the listener's perspective. It's not about the speaker. So depending on who you talk to, if you talk to boss or your wife, depending on that, your text would be more formal, informal, romantic, polite, whatever. This is called interpersonal group. The other group is called affective group. It's basically synchronize the affective status between the speaker and the listener. So we have the sentiments, emotion, romance, offense, etc. The last group is called the figurative group. So it's all about like a figurative speech of your text. So it can amplify your message, or it can make the communication more effective by using like a humor, sarcasm, or metaphor. I will not cover all the details, how we group this, and then what's the theoretical theory behind this grouping. You can check out the paper, but I like to highlight that each group has its own social roles in our social communications. Okay, and based on this group, we have the 3 questions. So first question is about style classification. So style classification application is given a text, your classifier, your model is to predict whether the text is polite or not, positive or negative, formal or informal, emotional or not, something like that. But because we have this multi-style annotated data set, we are curious to know that if you combine all the styles together and then train them all together, is it going to be make some improvements over this individual classifiers? So that's going to be the first case study I'm going to show you. The second study is to see which combination of styles are more highly correlated each other. The third study is about generation. So when multiple styles are combined in generation, how does the system generate the text condition on this multiple styles? And which combination is more effective and which one is more contradictory, something like that, yeah. Okay, so let's look at the first study first. So as I said, we have 2 different classifiers. One is individual classifiers trained individually on the separate individual style data sets. The other one is called cross-style classifier. So we train every like 15 different styles all together on this 23 style data set all together. So it's basically multitask learning, but we use some T5 based generative model to do this. We can talk about the detailed modeling parts later. And then if you look at the improvements between these 2 systems, you can see that when you combine all the styles and then jointly train them, we can achieve the better performance overall this 23 style test sets in general. So this is somehow interesting, but which styles are sharing their internal representations? Why there's some improvements when we combine them? Is it because some styles are correlated each other? So the next question is, which styles are correlated? So using the classifiers we built previously, we predict style values of 1 million tweets. and then calculates their Pearson correlations. So you can see this correlation metric like this. And we could observe some interesting correlation patterns. So for instance, humorous text is often positively correlated with text with excitement emotion, or text with negative sentiment, which makes sense in some sense, right? And also text with anger emotion is positively correlated with disgust emotion or offense. Text with formal text is quite positively correlated with text written by master level education, which is funny. So you can check out the paper to see more the more correlations from our study, and I'm happy to discuss more in offline. Okay, now we are talk about generation parts. So if we combine the state-of-the-art generation system like GPT-2 or 3 with the style classifiers we built, we can basically develop a generator conditioned on multiple styles. So for doing this, we use the PPLM model. So for instance, here's the output from the system. So given a prompt text like every natural text is, and then if we condition two styles like, oh, make the output like a negative emotion and polite text, and then the generator produce output like every natural text is different. You may find that the word you wrote does not appear on the website of the author. If you have any queries, you can contact us, blah, blah, blah. So you may see like the output text includes some reasonable features like different and does not is quite like a negative features, and may or you have any queries, these phrases are quite like a polite features, right? So, okay, so it seems quite working well. And then what we did is we produced 2x2 combinations of these two style labels. So we basically produce positive polite text, positive impolite text, negative polite text, negative impolite text. And then we evaluate the output from this system by asking humans to judge whether the output is containing the input combination of the styles correctly or not. So it's Likert scale. So, and then in some combination, like a positive and polites and negative and impolites, they have a higher appropriateness scores than the other combinations. Why? This is basically saying that there are some combination of styles that are more natural in terms of generation. And we also saw the similar correlation patterns in the previous correlation study on human written text, not just model generation. So in both human written text and also this model generated space, there are some combination of the styles that are producing more natural text or more contradicting text. So this research is still like at initial stage, and we are trying, our lab is trying to scale up to many other combinations and then try to make more controllable multi-style generation systems right now. So I'm happy to talk more in offline. Okay, and then one of the extension work we are actually doing right now is that previous work has some limitations. Like we got the correlation scores from these pre-trained classifiers, which are not that accurate. So we look at the correlation on sentence level. So in the previous study, we look at the correlation on the sentence level, right? But not lexicon level. So we extend our correlation study to the word level. So for instance, a given sentence like this, we make the system classifier, we use the BERT, by the way, BERT classifier to predict its politeness. So the sentence, input sentence here is, I will understand if you decline, but would very much like you to accept. May I nominate you? This and then for BERT classifier, it predicts correctly as polite, and also humans also predict it as a polite text. And then we also ask using some interpretability methods like a gradient based methods. We know like which words that this BERT classifier thinks are important. to believe this sentence as a polite. And then it turns out the BERT classifier thinks the word I, or will, or if you, or very much, or you, or accept. These are important words to believe this sentence as polite. We do this task to human annotators as well. And then human also label like understand, the word like understand, like, accept, may I nominate you as important words to predict this sentence as a polite. So as you can see, there's a huge discrepancy between BERT perception and the human's perception about this style. Why? And also, this is one particular example, but we scale up to many other sentences. And then you can see the top 4 words predicted by humans or BERT as important lexicons for this politeness classification. So you can see humans think like hilarious, thank, moved, good as an important words, but the model's predictions are quite random, like disappointed, scenes, suffers, high. Why? This is because our neural or our black box deep learning based models are really biased to the training data set. So by any chance, your model includes some frequent words, and then by any chance that those frequent words are like a co-occurring with particular label like a politeness, then just model believe those words, random words, are important words as well. So this is called a training bias problem, and this is really severe. And also, because of that, you can see some content words like scenes or movie, genre, they are all like categorized as important words for this kind of classifiers. So this entangle between content words and style words are one of the really important research direction in the style research. And using this human annotated data sets, we can make a classifier that can predict well, not only in the sentence level label, but also in the lexicon level label. So it can give you the better performance as well as the better interpretation of why you make this kind of predictions. So that work is under review right now. Okay, and then using this lexicon annotated data sets, we can do more precise correlation study. So, so basically, as you know, like we have this word embedding, right? Word embedding to get the vector array of each word. And then we believe these vectors are like a representation of your semantic meaning of that word, right? But we can do the same thing for style meaning as well. So we annotated not only for politeness, we also annotated these words for positive sentiments, offense, anger, disgust, many other styles. And then we can basically have this style embedding. So this word please has 57% of politeness, 3% of positive sentiments, 7% of offense, etc. So, and then take this style embedding, and then we can project all the words in this 2-dimensional space. And then you can see this clear distinction between content words and stylistic words, which is quite pretty interesting. And also, you can see similar kinds of styles like politeness, positive sentiment, joy emotion. They're close to each other. And also like in the middle, you can see like some emotional styles are also close to each other. And on the right top, you can see anger, negative sentiments, offense, impolite, they're also close to each other. So we can have a better precise correlation modeling of these styles using the style embeddings. And then we're, that's our one of our current work. And then besides that, we have multiple interesting challenges in this cross-style research. So we need to control this controllability of the generation system, this entanglement, as I said, multi-style generation problem, and how we can make a more precise taxonomy of the styles, and also like a lack of data set problem and so on. So there are many more. And then as a part of such efforts, we are actually making a controllable generation workshop with some friends at Stanford, CMU, Berkeley, Microsoft. And we're organizing this workshop at UTIPS this year. So feel free to consider submitting your work here. And we also have a fantastic lineup of speakers as well. Okay, so that's all about the style parts. And then before jumping into the interactive system parts, I will pause for a few seconds and take questions. Okay, seems no question. Okay, so okay, how can I start? You may have experience of deploying an NLP system trained on benchmark sets, and then deploy that system to your field. But you will observe that the system may never works in practice, right? Why? Why are many benchmark-based NLP systems are not practical and not robust to new domains? So in this chapter, I'm going to talk about our ongoing projects on building this more robust and practical systems and throughout the interactions. I call it interactive NLP system. Oops, sorry. Yeah, and then and if you like to develop a practical NLP system and then make it interactive with real users, probably the first thing you have to do is to narrow down your domain of applications and train your model specific to that domain. This is because there's no universal, like a magical NLP model that can do well on every domains. And each domain has its own NLP challenges. So here, my domain of interest is scientific research domain, or it's also often called scholarly document processing, not natural language processing. So it's called SDP, okay? And in this scholarly document processing area, our lab's goal is to develop a system that can improve researchers or scientists' research activities using NLP techniques. So for instance, how we can help researchers do reading, writing, or reviewing papers. For reading activity, the system can help different styles of reading experience, like skimming the paper, proofreading the paper, and so on. And also, in our project, our recent project is focused on improving the close reading experience. Close reading means we are deeply parse the paper and fully understand every details of the paper. And I'm going to talk about this in the later slides. Yeah. What about writing? When researchers write a paper, the system can auto-suggest the next possible text or mathematical notations to type in. Or the system can also detect inconsistently written text and then give some suggestions to fix it. When reviewing someone else's paper, a system can help reviewers' judgments or help verify the main claims of the paper automatically. So these are all like an active area, and my lab is also focusing on some of the sub-problems here. And these kinds of practical systems, NLP systems on particular domain, can contribute to improve our science community, science research community, right? But at the same time, there are many interesting new NLP challenges there when we try to developing this kind of systems. So this is basically a good synergy when we combine two fields, NLP and HCI. And today I'm going to briefly describe our recent and ongoing project on developing this reading and writing assistant tools for scientists. Okay. So in collaboration with Berkeley and Semantic Scholar team at AI2, we recently developed an intelligent reading assistant tool called Scholarify. So if you read a paper, you may often see that different terminologies are defined here and there, and these new defined terms are called nonce words. So it's not like existing words, but the author of the paper just defined it as a new term in this paper. So it can be like acronyms or it can be like symbols, mathematical symbols, or it can be totally like a new terms. And they are in fact a lot. So memorizing all of these new words while reading a paper is really painful, as you know, and that requires a lot of cognitive load for readers. So we developed an augmented reading interface that provides just-in-time, position-sensitive definitions of these nouns, and the system is called Scholarify again. So if you read a paper using our PDF reader, and if you click a term, acronym, or symbol using our PDF reader, then the system just pops up its definitions defined in that paper as in this tooltip. So it's like an interface, basically. And if you click a complicated equation like this, it pops up a diagram of definitions of each subscript and superscript and entire equations, etc. And also, some readers may prefer reading the paper as a PDF printed version. So we also have an extra PDF page at the end of the paper, and then we summarized all the definitions of the terms and symbols defined in the paper as a glossary table. So the beta version of our system will be released soon in the Semantic Scholar, and then Semantic Scholar, we use our reader as a default PDF reader. So you can also see some demo in the AI2 Semantic Scholar page as well right now. Okay, so, but the previous, this system shows, sorry. Yeah, so this one shows the quite intelligent interfaces that can make the reading experience way better. But now I'm going to discuss about the backend NLP system that can support these fantastic interfaces. So such as extracting definitions from the papers and rewrite the definition into more definition-ish forms, etc. I will not go all the details of our NLP applications, but what I like to focus here is that, here's the story. So in the first month of my postdoc, I took a benchmark set of this definition detection task, and then trained the model with the BERT, and then I fine-tuned it with the scientific papers and so on. And then I actually made a state-of-the-art system, and we got like a 75 F1 score. And then we were so happy, like we could make some sort of working version. But when we tested on the real user, and then in our like a beta version of the testing, it turns out our system only gives like a less than 50 F1 scores at the end. So there's a huge gap between this practical user testing with real users and benchmark sets. And then we collect the more data sets and then develop more sophisticated annotation schema. And we look into the error types. And then based on error analysis, we develop another model and then collect more data set. And then we repeat this whole procedure maybe at least like 3 times. So that was like a long, like year-long and painful workflow to make the system more practical and working as a product level performance. And we could ended up like having like a 95 F1 score at the end. But what I like to say is the most important thing to build a practical NLP system is develop sophisticated annotation schema and collect high quality data sets, and then do error analysis and then repeat these forever. So that was the one lesson that I learned from this practical experience. Anyway, and then throughout the error analysis, we also often find some interesting new NLP problems. So here's an example. So basically the model is supposed to detect all the pairs of symbols and its definitions. So you can see the B of PL and its definition is projected box on the right panel. And also look at the other patterns below. There are some complicated patterns like D of TL, D of LL, blah, blah, blah. And then the definitions sentence is quite complicated because the model needs to find the exact mapping between all this respectively patterns, right? For humans, it's quite easy to find these mappings, but for models, no. So we also collect the data set for handling this kind of new interesting coordination patterns, and then we could achieve pretty accurate NLP systems. And then we are working on writing a paper for this problem. Okay, so that's it. And then now using the similar techniques, we also improve the researcher's writing experience. So for instance, when you write a paper using maybe a LaTeX editing tool like Overleaf, the system may help you by flagging error messages of inconsistently used terms and then suggesting possible revisions like this. Or the system can show automatic clarity or coherence scores of your paragraph as some sort of indicator for better writing. Then do you think showing these measures in real time can help writing? So this is a HCI question, and our team is actually working on whether it's better or not, or whether it's effective helping writing or not, something like that. And also we can automatically suggest what symbols or terms to type in by understanding the context of what you have written so far in this PDF writing tool. The paper writing tool. So throughout these features, human writers and NLP models can interact and reinforce each other. And Berkeley team and Minnesota team we are currently writing a grant proposal for this interactive writing system tool for scientific papers. And I'm happy to discuss all the details and technical stuff in offline, of course. Okay, and my vision is I like to transform our scientific activity from writing or reading to like an interaction with NLP models. That was like a dream vision in my lab. Yeah. Okay. And then it's a little more details, but as an algorithm part, we are actually working on building some more dynamic data sets by making some interactive annotation system. And also we are taking the human's feedback on these interfaces and then reinforce the analogy algorithm based on this human implicit or explicit feedback from the users. So that's some technical parts of our work. Okay, so let me conclude my talk. So going back to my original approach, and in order to develop more human-centered NLP system, our group is building some interdisciplinary NLP models and also some interactive NLP systems, right? And then today we covered some theory and also one of the aspect which is called style and how we can computationally modeling this multiple styles in analogy system or NLP system. And then I introduce some of the ongoing reading and writing assistant tools. Okay, and then let's go back to this original question, what factors are there? So today I only covered two aspects, social cognition or styles and interactions. But in fact, there are many other factors like a causality, abstraction, and so on. And my group is actually working on the other aspects as well. And the individual students are working on individual aspect here. So I'm happy to talk more. And then as an example, we also developed some dialogue, some generation systems which can do some planning and control the discourse structure of the text. Or we also developed dialogue systems. We make the dialogue systems more goal-oriented by setting some explicit goal or by setting some implicit social goals, and then optimize the model using reinforcement learning. And we are also interested in developing some neural symbolic systems and non-biased NLP systems. So I'm happy to talk more about these topics in offline. And then this is my last slide. Okay, so my last slide is about my long-term vision about this human-centered NLP research. So as I said, based on these theories in linguistics and cognitive theories, we can develop some computational models that can handle each of these facets. So my next step is to make these individual modules connected each other and then make them as a dynamic network, which is basically a multifaceted system. But this is really difficult, challenging problem. So I hope, I believe this is gonna be like a long-term plan, maybe for next 10 or 20 years. And then on top of this, we can build an interactive system that can collaborate and interact with the real users. So for instance, we can help scientists or researchers using reading and writing assistant system that I described today, or we can extend it to fiction writers, journalists, developers, etc. So sometimes, and also sometimes from these practical system developments, we may find something new that may conflict with the traditional theories in this linguistics or cognitive theories. So we can update those existing theories from our practical experience sometimes as well. So this is our group's long-term research vision. And then I'm going to conclude my talk. Okay. Yeah.
Thank you so much, DK. This is so interesting and so relevant for the work that we're doing. And I think we have a few questions. We will go over time, but it'll be great if people can hang out while we answer the questions, or we can get to the questions in the networking session as well. So we can start with the first one. At least we can get through one for now. So this came from David. What was, and this is on the work on style. What was the background of the human annotators in the paper under review, which was on identifying components of the text associated with different styles? And the second question is, follow-up is, did they have a background in writing, linguistics, or some language-related fields, or were they average users or speakers?
Yeah, that's really good question. So the goal of this lexicon level annotation was not making consistent and high accurate annotations, but we wanted to collect more general human perceptions from average users. So we had very little restrictions on choosing annotators, like native speakers, people from UK and US, and we didn't ask for extensive linguistic background at all, because we believe the style perception, people have different backgrounds, and based on that background, we wanted to collect not just a single answer, but we wanted to collect a distribution of multiple people's perception. So as you can see in the previous example, we didn't highlight each lexicon word as a single color, but you can see some gradation, right? So we collect all these agreement scores over multiple, like 5 annotators for each word, and then we provide that the floating value of each word as a final annotation. So, and in terms of agreement, so in the review, it was submitted to EMNLP and the review was pretty positive. But one concern from the reviewers was like just criticizing about this relatively low agreement scores. But we defended well by saying that getting the higher agreed score on this task is not our purpose. We admit that there are some inconsistency across the annotators about this task, and we wanted to collect those variation of the annotations. Okay, and did they have a background? Yeah, okay. Does that make sense?
Yeah, I mean, to me it does, David. Okay, yeah. Great, thank you so much, DK. So the next question came from Dima, which I had that as well. Could you tell a little bit more about styles correlation matrix, the one in the second work, and what styles correlate, and maybe also what style groups emerge from that, or what kind of research are you doing on information like that?
Good question. So so ideally, we wanted to make some theoretical grouping of this multiple styles first. So I talked to many other people who have some linguistic backgrounds, and also many other professors in linguistic department as well. But people have a totally different perspective of the styles. So we couldn't have a good theoretical taxonomy of the styles. And also there are some very fuzzy and hierarchical styles, like your personal style, or the style of other some random groups or something like that. So it's really difficult to make a clear taxonomy of the styles. And then we decided to make some empirical grouping down. So that's why that was the motivation of the study. And then we could have some this how can I say, this cluster of bottom up clustering of this styles based on this correlation study, and we could come up with some sort of grouping at the end. But the thing is, it can do well in this low level grouping, but we couldn't find any high level grouping though. So I was expecting like a metaphor and sarcasm, they are more high level, and maybe like a demographic styles are more low level. So somehow there must be some hierarchy of these styles, but we couldn't find it. So, and I'm not sure whether this is because the way that we got the style values from the classifiers are wrong, or the other side is we annotate them from human annotators, but the size was pretty low. So we could come up with the good correlation, significant scores out of it. So we are kind of like in the middle of the scalability issue and also accuracy issue. So we got stuck, to be honest, but we are actually making, we are writing some positional paper about the style taxonomy. And then rather than having some concrete conclusion in the paper, we are right now we are interviewing all the NLP professors in different places, and then show them our position paper, and then collect the feedback from the others. So that paper is on the in progress right now. So you can read it later. Yeah. And you will get some sort of insights about this grouping and correlations, yeah, from some broader audience, yeah.
That's really interesting.
Yeah.
I guess one sort of modification would be, do you think we can model like communicative personalities, like you mentioned, scientist, a scientist communication will mostly, I mean, it may vary by their first language, it will probably be formal, mostly polite, and so on. That's like a different kind of grouping based on the texts.
Yeah, depending on your workplace, or depending on the physical location of your group, that's gonna be another style. Yes, I agree. Yeah. So on top of this low-level linguistic style, I think there are so many different ways of the styles. Yeah, I agree.
Okay, great. So the next question is from Mark. Mark says, I want to ask about human and BERT perception of important words for politeness. You mentioned training bias, but I also wonder if the relationships between styles also plays a role. If you ask a human to evaluate a sentence for politeness, they're probably not only assessing politeness, but related styles as well. Could this difference also affect these differences between human and BERT?
Interesting question. So in our annotation task, we make this annotation separated across the styles. So we haven't do like a controlled experiments, like when people are annotating multiple styles on the same text versus different people are annotating different styles, and then see which one is more consistent or something like that. But I think that's going to be a really interesting study. And in comparison between human and BERTs in this multi-style setup, interesting. Yeah, I think that's really interesting question, future direction. So let's say you're given a text and you're supposed to annotate particular style versus you're supposed to annotate multiple styles. How does that affect your annotations? I haven't thought about it, to be honest, but that will be really interesting topic. Yeah, thanks for the suggestion, Mark. Yeah, I think it's a good direction, yeah, to go. Yeah. And I'm pretty sure if you are supposed to annotate multiple styles at the same time, it will slightly change your annotations for sure. Yeah. And we only look at this multi-style relationship in models generation only. but not in the humans annotation yet. Yeah.
Okay, let's go to Igor's question next. Are there any published models or training data sets that could be used for multi-style classification?
Yeah, so you can actually look at our data set, XLU, and we annotated multiple styles. But the thing is, this multi-style annotated data set, because of the budget limitation, we couldn't annotate a lot of training data set though. So we only collected some diagnostic test sets for evaluation purpose. But for training, so that's why I think this is a good problem. So you have the separate data sets for individual styles, and how we can effectively model this multi-style variation by using this separate data sets. And you have the designated some evaluation set for multi-style annotated. So there might be better way to improve this internal representation of multiple styles rather than simple T5 based multitask learning. So I think it's impossible to collect huge number of the training data set of multi-style annotated. So given this limited resource, I believe we can do better than what I did. So yeah, that's my take.
Okay, thank you. The next question is from Roman. How did you map words or embeddings to their style distributions? In the example, it was please is 60% politeness and 10% some other style, etc.
Yeah, good question. So as I said, we ask annotators to label each word, and then we have multiple annotators, like 5 annotators, and then we average their scores for each word. So we will basically have scores of like a 20%, 40%, 60%, 80%, etc. Right? And then we collect all this style variation, style annotation scores over multiple sentences, and then for each word we can have this aggregated scores over the multiple sentences. So this 60% of politeness means many people think this word please plays important words. There is a 60% of agreement across the annotators and across the sentences. So that's how we get the embedding scores. And then based on this, yeah, we just predict to 2-dimension using PCA or TNSE. Yeah, whatever.
Okay. Thank you so much, DK. That was it from the questions. Yeah, I have to say this is like one of the most like interesting and really engaging presentation that I've attended in a while. So thanks for doing this. Thanks for taking the time to share your work with us. And so yeah, everyone, thanks for attending. The official part is now over. Thank you for joining us.